Question 13 asks you, which of the following amino acid side chains could bind to metal ion? Tyrosine, alanine, cysteine, isoleucine, asparagine, aspartate, and tryptophan. Well, in order for, one of the things I discussed with you guys, when we have a metal ion, let's say, take an iron, for instance, iron 2+. Right? These metal ions, in general, like to interact with lone pairs of electrons on atoms around them. Now, it's even better if there's a negative charge on whatever atom this is, atom X. If it also has a negative charge, that's even better. But it's sufficient for it to have a free lone pair of electrons that can basically donate to this metal. Now, so the question is really asking you here, which of these amino acid side chains have free lone pairs of electrons? Well, we'll start with the ones, I'll give you the answer here. So the correct answer is tyrosine, cysteine, asparagine, and aspartate. All right, those are 4 that can possibly bind to metal ions. Alanine, isoleucine, and tryptophan cannot under normal conditions. Now, why is this? Well, tyrosine on the end has this OH group, right? And the OH, to begin with, has these 2 lone pairs of electrons, which are free and combined to a metal. In addition to that, we know that tyrosine can get deprotonated and become negatively charged, the side chain. And so, because of this, now we have numerous lone pairs of electrons and a negative charge, so tyrosine is an ideal case. In addition, all right, move on to the next case here. Cysteine is very similar in this regard. So cysteine, for instance, if I could get my pen to work here, cysteine has an SH group, which can get deprotoned, become an S-, and so it has lone pairs of electrons, and it can have a negative charge. Therefore, it is potentially very good at binding to metals. All right, asparagine at the end asparagine has this structure shown here at the end of it. Now, the nitrogen here, you might think that the nitrogen lone pair of electrons could potentially donate to the metal. Well, the thing you have to remember about this lone pair of electrons on the nitrogen is that it's actually locked into a resonance structure here with the oxygen. All right, so because of that, the lone pair on the nitrogen isn't really available for hydrogen or for donating to metals. On the oxygen, however, we do have 2 lone pairs of electrons. Now, this oxygen atom typically is not going to have a negative charge to it, and so because of this, it's not as favorable for asparagine to bind to metals, but it is nonetheless capable of doing so. Right. Aspartate has a carboxylic acid, and on the O- here, we have 3 lone pairs of electrons and a negative charge, so hopefully that one's pretty obvious to you. Now, alanine and isoleucine, these guys up here, they are not capable of binding to metal ions because their side chains are entirely, alkane type structures where, we have a bunch of CH groups, right? So alanine, we just have a methyl group on it. Isoleucine has a more complicated alkane, but nonetheless an alkane, and alkanes don't have free lone pairs of electrons. Now, the last one to consider here is tryptophan. Now, tryptophan, you might be thinking, right, on the side chain, it has this nitrogen here, right? And it's an NH, so that means that there's a lone pair of electrons on the nitrogen. But that lone pair of electrons on the nitrogen are actually participating in the aromaticity of these 2 rings. So as a result, the lone pair on the nitrogen there is not available to bind to metal ions.